This is an explanation for the question 3 on the exam review. It reads that a car starts from rest, accelerates at a rate of 3 meters per second squared for 30 seconds, then travels at a constant speed for 60 seconds, and then slows down at a rate of 2 meters per second squared. You're making the assumption at the end that it's going to slow down to a rest, of course. So follow the problem solving process. The first part of the trip, it starts from rest and accelerates at 3 meters per second squared for the time of 30 seconds. You have to determine how far it travels during this time first, then it travels, second part of the trip, whatever final velocity it achieved here, it's going to travel at that constant speed. For 60 seconds. So that's another distance that has been traveled. And so you have to find that part. And then the last part, whatever top speed you achieved here during this first part and also maintain during this second part, you're going to go from there down to stop. So your final speed is going to be 0 at a rate of 2 meters per second squared. Notice it did not tell you the time. Of course, you don't need the time in this part because you would have already found that velocity, that constant velocity that you were traveling at when you started this deceleration. And the final velocity, of course, is, for this last part, 0. So, solution to the problem is straightforward. Apply the problem solving process. You got to do it for 3 parts. Let me erase so that you can still see what I'm doing here. Let's find, for this first part, the distance traveled. We'll just call it delta x1. I'm going to skip some of the steps. I'm trying to be as brief as possible. We have the initial velocity, we have the acceleration, we have the time. We want to find the distance traveled. That's your unknown. So we're going to use the kinematics equation. For this part only, we're going to call it delta x1. The initial velocity during that part, of course, was 0. So this entire term drops out. And so delta x1 is just simply 1/2 times 3, 30 seconds squared. You can work out that part. Not having my calculator with me, I wouldn't try to guess. Of course I can do it. So that's our delta x1. Now, what is the speed? This final speed for this first part, because you're going to need that in your second part of your problem, because you're going to travel for 60 seconds at that constant speed you achieve in this first accelerated part. So let's determine that. Using the same information, except this time we're looking for the final speed over this interval. These are your unknowns. The equation that relates initial velocity, acceleration, time with the final is that equation, right? You have your initial velocity 0, your acceleration, and your time. Meters per second. Okay. You're going to travel at 90 meters per second for 60 seconds. So how far do you travel? Keep in mind, this is at a constant speed. So graphically, it looks something like this. If we were to plot speed as a function of time, for the first 30 seconds, you accelerate it at 3 meters per second. That's the slope of your velocity curve for 30 seconds. You then travel for 60 seconds at a constant speed. And then you slow down to a stop. So you're going to have to find delta x1, delta x2, and delta x3 in order to solve the problem, how far did you travel? Now, we have our delta x2. That, of course, is 5,400 meters. And for the last part, delta x3. This was your initial velocity over that interval, and your final velocity over that interval. 0. Look at the information that you have for this part, the givens that you have for this part, and find an equation that relates the given information with the unknown. The unknown is delta x3. The givens, your initial velocity, your final velocity, and your acceleration. The equation you're going to use, notice there's no time, is the f squared minus the initial square equals 2a delta x3. So delta x3 equals 0 squared minus 90 squared divided by 2 times negative 2. Let's put the negative outside. So our delta x3 is 25 meters. So in total, $87.75.